I'm Humayra and welcome to Roots of Unity. Today we will be looking at partial fractions. Let's start off by doing a sum. Say we have 1 by x plus 1 minus 1 by x plus 2. Now to solve this, our first step is to do the LCM. And you can see that both these fractions have different denominators. So our LCM will be x plus 1 into x plus 2. Now in our first fraction, our denominator does not have x plus 2, but it has x plus 1. So what we do is, we multiply the numerator with the term of the LCM that it doesn't have, which is x plus 2. So we multiply 1 into x plus 2. Similarly, we will be multiplying x plus 1 with minus 1 to get minus 1 into x plus 1. Now if we solve this, we will get something like this. So our answer is 1 by x plus 1 into x plus 2. And these types of sums you might have been doing for quite some years now. But our topic of concern today involves the reverse process. What if we want to go from here to here? Now you might be wondering, Humayra, you're crazy. After all these years of learning how to solve algebraic sums like this, why would I suddenly want to go backwards? Well, that, my friend, is because as we delve deeper into more complex sums, sometimes, in order to simplify our calculations, we need this step so that we can reach our final result. And as we start our topic today, you'll realize that splitting these types of expressions is actually fairly simple. So what I would like for you to do today is try to solve these problems with me, so that by the end, you can be a pro at solving partial fractions as well. Now in this video series, we will be looking at 4 types of partial fractions. We will be looking at partial fractions with simple denominators, denominators with repeated factors, denominators with a quadratic factor, and finally, improper fractions. So let's take a look at the sum that we already solved and try to work our way backwards. And we can see here that our denominator has 2 linear factors, which means that our answer should look something like this, where both a and b are constants. You'll also notice that we have 2 fractions, each having the 2 separate factors as denominators. So now all we have to do is solve a by x plus 1 plus b by x plus 2 like we normally would. We'll need to find the LCM, which is x plus 1 into x plus 2, and solve the math accordingly. So we should arrive at something like this. Now notice here that I've kept the terms in x together while keeping the constants separately. Now after this step, we cannot simplify this any further. So we can conclude that all we have to do is equate the terms. Our question had no terms in x, which means if we equate the value of x, we get a plus b is 0. And if we rearrange this a bit, we get a equals to minus b, which is our first equation. Now our constant term was 1, so we can write 2a plus b is equals to 1. Now if we put the value of a in this equation, we get our answer b equals to minus 1 and a equals to 1. Putting this in our format, we get our answer 1 by x plus 1 minus 1 by x plus 2. Now all we have to do is solve another sum and then we'll be done. Now for this sum, you'll notice that we have 3 factors in our denominator. But don't worry, there's really nothing to be intimidated by this. In fact, we'll also be learning a shortcut later on. Anyways, now the first thing we notice that all our factors are linear factors, which means our answer will look something like this: a by x plus b by x plus 1 plus c by x plus 2, where a, b, and c are constants. Now our LCM this time is x into x plus 1 into x plus 2. Solving, we arrive at this. Now remember that we're only concerned with the numerator for this part, and we have 2 equations, this one and this one. And for this sum, we'll be trying something a bit different. First, we are going to be putting the value of x equals to 0 in both the equations of the numerator. So solving, we should arrive at a equals to half. Now all we have to do is put our value of x equals to minus 1 and x equals to minus 2, and we should also get our values of b and c, which are b equals to 2 and c equals to minus 5 by 2. So finally, we arrive at our answer 1 by 2x plus 2 by x plus 1 minus 5 by 2x plus 2. Now, suppose you don't want to go through all the trouble of doing all these steps, or you're in a time crunch and quickly want to check your answers. This shortcut is right for you. Now our question is 3x plus 1 by x into x plus 1 into x plus 2, and we know that our answer should look something like this. Now for our first fraction, x cannot be equals to 0, since then we will get an undefined value. For our second fraction, x cannot be equals to minus 1, and for our third, x cannot be equals to minus 2. And we also have three partial fractions. So our first step would be to write the question 3 times, like this. Here, we will put x equals to 0 in our first fraction, x equals to minus 1 in our second fraction, and x equals to minus 2 in our third fraction, except for the factor in the denominator for which these values of x aren't valid. So we should arrive at our answer, and it will look something like this. So here you have it. And this way you can solve this sum in just 2 steps. Now I'll tell you why this works. Remember from when we first solved the sum, our numerators were equal and the equation looks something like this. And here we put the value x equals to 0 for our first fraction. Now for this part, we'll also be putting x equals to 0, but I'll be doing this in 2 parts so that it's easier for you to understand. For our first part, we put x equals to 0 in our terms b and c, and so we get these 2 terms as 0 now. So now we end up with something like this, and we get a is equals to 3x plus 1 by x plus 1 into x plus 2. And again here, we will put x equals to 0 so that we end up with the value of a as half. Similarly, in our shortcut, if you'd remember, we put x equals to 0 in our question, which was 3x plus 1 by x into x plus 1 into x plus 2. Here, if you take 1 by x common, our expression will look something like this. And you'll notice that this is actually our a. So we can substitute and write this as a by x. And as you can see, this is why the shortcut actually makes sense. So this is all for today's video. If you thought that was helpful, stay tuned for my next video where I talk more about the different types of partial fractions. If you have any queries or suggestions, please comment down below. And thank you so much for watching and have a great day.